Hello everyone. Let's solve question number 14 from the book Pathfinder. This question belongs to the Check Your Understanding section of the kinematics chapter. Water flows out in all directions with the same speed from a sprinkler, consisting of a perforated spherical shell fixed at the end of a hose. When a sprinkler is fixed to the ground, the maximum height attained by water stream is h. If the sprinkler is shifted to a height h above the ground, by what factor does the watered area on the ground change? Neglect the diameter of the spherical shell compared to h. Now let's solve it. The first piece of information given is that when a water stream is projected vertically upward as shown here, it reaches a maximum height h. So first thing we are going to do is to relate h and u. It's quite simple. Just apply the third equation, v being 0, and we have this relation u as equal to root 2gh. Now it's given in the question that when the sprinkler is placed on ground here, then the maximum distance the water can reach is r1. So this is the maximum range. We know the formula for range, u square sine 2 theta by g. Since theta is 45, 2 theta is 90, so it becomes u square by g. And putting the value of u square as 2gh, it comes out 2h. Now the second case. Now the sprinkler is somewhere here, h height above the ground, and suppose this stream goes to the farthest point on ground, and suppose we join the sprinkler and the point where stream lands by this straight slant line, and suppose this distance is r max. Now what we are going to do, this is the main thing of the question, the main point of the question. What we are doing, this is the key idea. If we imagine this line as an inclined plane, then the projectile is effectively projected on this inclined plane. Now using the standard result for maximum range on an inclined plane, we have this relation. Simply put u square as 2gh in this expression. G gets cancelled. Then from this triangle we have the value of sine beta as h over r max. Now cross multiply and solve. So you're getting r max is equal to 3h. Now apply Pythagoras theorem. R max is under root of r2 square plus h square. Squaring both sides, then solving for r2. So this is the maximum range when a sprinkler is placed above the ground. And now we have found R1, we have found R2, the ratio of R2 and R1 is root 2. In the question we have to find the area, the ratio of area covered by the water. So that is simply pi R2 square divided by pi R1 square. So that will come out equal to 2. So this was the question, and this is a beautiful problem because if you try solving it using calculus and maximum minima, the solution becomes quite lengthy. But by using a standard result from projectile motion on an inclined plane, the entire problem gets solved in just a few lines. So I hope you enjoyed this elegant approach. Okay, thank you.